Okay, so now we're going to try to use the slope formula or the gradient formula in order to calculate the speed. If you remember, the slope is just the rise over the run. Okay, just the rise over the run. So if we follow the graph from the start point, which is here, all the way up along to that first, the end of that first line, we can see that it has risen from a distance of 0 meters all the way up to 50 meters, which is here. Okay? So that means that it's risen by a positive 50 meters. It's gone up 50 meters, which is plus 50. And the time that it's done it in, it has run, is 5 seconds. So 5 seconds there. So now I just have them in my formula, rise divided by the run. It's 50 meters divided by 5 seconds, which is 10 meters per second. Okay, and that's speed number 1. If we now look at speed number 2, so speed number 2 is again going to be the rise divided by the run. So speed number 2 is for line 2, and we know that it's stationary, and we know that the answer should be 0, but let's make sure that the math says that as well. So if you notice, from the start of this line here, all the way to the end of this line over here, the rise is actually 0. It hasn't risen at all. So that's 0 meters, but at the same time, time has continued on from 5 seconds all the way to 10 seconds. So that's another 5 seconds. Okay, now it's a very, very common mistake here, is that people will use 10 seconds for that second time, but it's not, okay? You're looking at the time interval between the start of that line to the end of that line, okay? And that's just 5 seconds, because it goes from 5 seconds all the way to 10 seconds. So 0 divided by 5 is 0 meters per second. So that means speed number 2 is 0 meters per second. So that's how you would use the slope or the gradient formula to calculate the speed from a graph, from the measurements given on a graph. You just follow the rise divided by the run, and that will give you your speed. Okay, so get and practice this on the example problems below.